What do anesthetics, insecticides, and even fire extinguishers have in common? They all contain alkyl halides. If you name them right, you can master 50% of organic chemistry. Hi, I am Dr. N. Swathi. Let's decode alkyl halides today in the smartest way. So what are alkyl halides? Alkyl halides are also known as haloalkanes. These are organic compounds where one or more hydrogen atoms of an alkane are replaced by a halogen such as fluorine, chlorine, bromine or iodine. And they are represented with a general formula Rx. So these alkyl halides are considered as the functional derivatives of alkanes, where alkane's general formula is RH. So this hydrogen of alkanes, when you replace with halogen, we will get alkyl halides. So a few examples for alkyl halides. If you replace one of the hydrogen in methane with chlorine, then we will be getting methyl chloride. Similarly, if we replace one of the hydrogen in ethane, so this is the structure of ethane. When you replace one of the hydrogen in ethane with bromine, then we will get ethyl bromide. So these are the few examples for alkyl halides. So alkyl halides are having greater pharmaceutical and industrial importance. These are used in the synthesis of drugs, anesthetics and agrochemicals. A few examples are CHCl3. So this is known as chloroform, which is used as anesthetic agent. This is another example, halothane, which is also used as anesthetic agent. And another example is iodomethane, that is CH3I. This is used as methylating agent in methylation reactions. And these alkyl halides are key intermediates in nucleophilic substitution and elimination reactions. And these are also building blocks for complex molecules in medicinal chemistry. Now, how we can name alkyl halides? So they can be named based on common naming system and also IUPAC system. So in this common naming system, the nature of alkyl group present will be represented in the prefix. That means we have to see whether a methyl group or ethyl group or propyl or butyl group is present in the given compound. Accordingly, the nature of alkyl group should be indicated in the prefix. Then the suffix contains the nature of the halogen. So we have to identify which type of halogen is present in the given alkyl halide. Accordingly, that information we have to give in the suffix. So the word alkyl halide itself is the common name for these molecules. So let us consider few examples. So in this example, it is CH3F. The nature of alkyl group is methyl group. So that is indicated in the prefix. And the nature of halogen is fluorine. So that is indicated in the suffix. So it is named as methyl fluoride. Another example, the nature of alkyl group is 2 carbon containing chain. So it is known as ethyl group. Okay. And the nature of halogen is bromine. So it is known as ethyl bromide. One more example. So when 3 carbons are present in straight chain form, that is known as propyl group. So we indicate that in the prefix. And the nature of halogen is iodine. So that we indicate as iodide in the suffix. Another example. So here the nature of alkyl group is isopropyl group, because halogen is not present on any one end of the carbon chain, but it is present in the mid carbon. So that means it is a isopropyl group, and the halogen nature is bromine. So we write it as isopropyl bromide. And another example, you can see here, this is isobutyl group. Okay, that is total 4 carbons are present in this alkyl group, and it is a branched chain. So it is an isobutyl group. Okay, and the nature of halogen is chlorine. So we indicate that in the suffix. So this becomes isobutyl chloride. So this is how the nature of alkyl group should be indicated in the prefix, and nature of halogen should be indicated in the suffix as per the common naming system. When it comes to IUPAC system, the IUPAC naming of alkyl halides is exactly same as that of alkanes. So the first step, we have to identify the parent chain. So that is the longest continuous carbon chain should be identified as the parent chain. If this chain is having 3 carbons, then it should be considered as propane. 4 carbons means butane and 5 carbons means pentane. So we need to first identify the longest continuous carbon chain in the given molecule. Now the second step is we have to number the carbon chain. While giving the numbering to the carbon chain, we should always consider that the carbon bearing the halogen should get the lowest possible number. If you consider this example, the carbon chain can be numbered from left hand to right hand side. Okay, so that is 1, 2, 3, or it can be numbered from right hand side to the left hand side. Like the halogen bearing the carbon, we can give first position, then 2, then 3. Okay, so in option A, if you number the molecule, okay, like this, in that case, the halogen bearing carbon gets the third position. On the other hand, if you number the carbon chain like B, then the carbon bearing the halogen gets the lowest possible number. So that is the reason we have to follow now the B option. So always we have to number the carbon chain such that the carbon bearing the halogen should get the lowest possible number. Now the next step is we have to identify the halogen present in the given molecule and name the halogen along with the position at which the halogen is present. So this information should be provided in the prefix. Okay, so if you consider the same molecule, same example here, the nature of halogen is chlorine and it is present at first carbon. So it can be named as 1-chloro and the parent hydrocarbon is having 3 carbons. So it ends with propane. So the IUPAC name for the given structure, it is 1-chloropropane. So this is how we have to name alkyl halides. So usually in the IUPAC system, if you look at the format of naming any molecule, it will contain prefix, then followed by stem or root word, then suffix will be there. So the nature of halogen and the position of halogen in case of alkyl halides will be indicated in the prefix. Then the number of carbon atoms should be indicated in the stem, followed by that the nature of the functional group. That means here in case of alkyl halides, it is the functional derivative. Alkyl halides are the functional derivatives of alkanes. So the suffix should contain ane. It should end with ane. So if you consider this particular example, the parent chain is having 3 carbons. So we can write propane in the suffix. The nature of halogen is bromine. Now this bromine group is present on second carbon atom. So we write as 2-bromo in the prefix. So the nature of halogen along with its position should be indicated in the prefix, followed by that stem means the carbon chain parent hydrocarbon contains 3 carbons. So we write it as pro and it is a saturated chain. So that's why the name should end with ane. So the name of this molecule becomes 2-bromo-propane. So this is how the IUPAC name of alkyl halides should follow the same form. Now let us consider few examples. So in case of first example, the common naming is already given. It is methyl chloride. So as per IUPAC system, the parent carbon here is parent chain here contains only 1 carbon. That means it is methane derivative. The nature of halogen is chlorine. So we can write it as chloromethane. Now coming to the example 2, the parent hydrocarbon here contains 2 carbons. That means we can write the word ethane in its suffix. Coming to the nature of halogen, here it contains bromine. So we can write it as bromoethane. Now in case of third example, the parent chain here contains 3 carbons. Okay, so we can write it as propane. Now coming to the halogen, it is iodine. Now this halogen is present on first carbon. So here we have to number the carbon chain such that the carbon bearing the halogen gets the lowest possible number. So that means here this carbon gets first position, then 2, then 3 for the rest of the carbons. Now the name of this molecule, it becomes 1-iodopropane. Another example, so this is isobutyl chloride. So here if you see the parent carbon chain, if you see, this is isobutyl group. but we have to consider the parent chain which is having continuous carbon. So then in that case, the numbering becomes like this: 1, 2, 3. Now this 3 carbon containing system means the parent chain or parent hydrocarbon becomes propane. Now this propane chain is having 2 types of substituents. At first position chlorine is present and at second position methyl group is present. So the nature of both the groups along with the position should be indicated in the prefix. So the name of this molecule, it becomes 1-chloro 2-methyl propane. Okay. So the molecule may have more than one halogen also. So in that case also, both the halogens along with the position should be indicated in the prefix and in the alphabetical order. Okay, both the halogens or the substituents should be indicated in alphabetical order. Prefix to the name of the hydrocarbon. So if you consider this example here, the molecule contains 2 halogens. Okay, so first number the molecule. So that is 1, 2, 3 carbons. So first position chlorine is present, second position bromine is present. So parent hydrocarbon contains 3 carbons, so it is propane derivative. Now when you are indicating the nature of halogen, so 1 chlorine, 2 bromine, okay, but they have to be indicated in the alphabetical order. So that is the reason 2 bromo comes first. Okay, so B comes first rather than C. So that's why it is written as 2 bromo 1 chloro propane. So this is how we have to follow this particular format, that is prefix followed by that root word or stem and then suffix for naming the alkyl halides as per IUPAC system. Now coming to the classification of alkyl halides can be classified based on the number of halogen atoms present in the given molecule, or they can be even classified based on the nature of carbon to which halogen is attached. Now let us consider first the classification of alkyl halides based on the number of halogen atoms present. So based on the number of halogen atoms present, they are classified into 3 types. Monohalides or monohaloalkanes. So where the alkyl halide will be having only one halogen. So the example is here, if you see in this structure only one halogen is present. Okay, so the alkyl chain, the parent hydrocarbon is ethane. So this can be written as chloroethane, which is an example for monohalide or monohaloalkane. Now the given alkyl halide may have 2 halogens also. So they are known as dihalides or dihaloalkanes. So let us consider an example for that also. So here in the given molecule 2, if you see 2 carbon chain is present. So that means the parent hydrocarbon is ethane. Now these 2 carbons are having 1 chlorine each. So we have to indicate their position also. So we will write that in the prefix. So it is written as 1, 2. 2 chlorines are present. So we indicate the that multiplicity in terms of di. So we write it as 1, 2 dichloroethane, which is an example for dihalides. Now the given alkyl halides may have 3 halogens also. In that case, it is known as trihalide or trihaloalkane. The example is trichloromethane. So you can see here the parent hydrocarbon is containing only 1 carbon. So it is written as methane. That means it is a methane derivative. So in the structure of methane, 4 hydrogens will be there. So out of 4 hydrogens, 3 hydrogens are replaced with chlorine. So we indicate that in the prefix. So it is written as trichloromethane, which is an example for trihalide. So this is how, depending on the number of halogens present in the molecule, alkyl halides are classified into mono, di and trihalides. Further, these monohalides are classified into primary alkyl halides, secondary alkyl halides and tertiary alkyl halides depending on the nature of carbon atom to which the halogen is attached. Now let us consider those details. So the first one is primary alkyl halide. So in this alkyl halide, halogen is attached to a primary carbon. So let us consider this example. So here the halogen is chlorine, which is attached to a primary carbon. So this carbon is considered to be primary carbon. Now what is the meaning of primary carbon? when a carbon is attached to only one other carbon, that is known as primary carbon. So here this carbon, first carbon is considered as primary carbon because this in turn is directly attached to only one another carbon. So that is why this carbon, first carbon, is known as primary carbon. As halogen is attached to primary carbon, so this is an example for primary alkyl halide. Similarly, another example, here iodine is the halogen and it is attached to again primary carbon. Because this, if you number the system, it becomes 1, 2, 3. Here the first carbon in turn attached to directly only one carbon, that is the second carbon. That is why the first carbon is considered to be primary carbon. So here also halogen is attached to primary carbon. So that is why it is considered to be an example for primary alkyl halide. The second one is secondary alkyl halide. So in this, the halogen is attached to a secondary carbon. So that means when carbon is attached to two more carbons, that is known as secondary carbon. So in the structure of isopropyl chloride, chlorine is attached to a secondary carbon. So why it is a secondary carbon? Because this carbon in turn attached to two more carbon atoms. So that is why isopropyl chloride is an example for secondary alkyl halide. Tertiary alkyl halides. In this case, halogen is attached to a tertiary carbon. Means when a carbon atom is bonded to three other carbon atoms, that is known as a tertiary carbon. So when halogen is attached to a tertiary carbon, that is known as tertiary alkyl halides. So if you consider tertiary butyl chloride, here chlorine is attached to a tertiary carbon. So here why this is known as tertiary carbon? Because it is in turn attached to three more carbon atoms. That is 1, 2, 3 more carbon atoms it is attached. So that is why tertiary butyl chloride is an example for tertiary alkyl halide. So this is how, depending on the nature of carbon to which halogen is attached, they were further classified into primary, secondary and tertiary alkyl halides. So all these three are the subclasses for monohalides. So alkyl halides are nothing but halogen substituted alkanes. That means we get alkyl halides upon replacing either one or more number of hydrogens in the structure of alkanes. And they are widely used in pharma industry and also in organic synthesis. As per common naming system, the nature of alkyl group should be indicated in the prefix, followed by the nature of halogen should be indicated in the suffix. When it comes to IUPAC system, first we have to identify the parent chain and that should be indicated in the suffix. The nature of halogen and the position at which the halogen is present should be indicated in the prefix. So that is how IUPAC name should be written. Now coming to the classification, based on the number of halogens present in the molecule, they are classified into mono, di and trihalides. Further, monohalides are classified into primary, secondary and tertiary alkyl halides depending on the nature of carbon to which halogen is attached. Master these basics because they form the backbone for many drug synthesis pathways. If you have any doubts about alkyl halides, drop your questions in the comment section. If this video is useful to you, then like and share it. And if you want more bite-sized organic chemistry lessons, hit the subscribe button and stay tuned for my next coming videos. Thanks for watching. I'll meet you in my next video.